right, so this section, okay, it is going to be obviously the 3.2 stuff. If you haven't watched the video, you really won't be that behind. You've definitely done this before in Algebra 1, so it should be a review. Okay, I know technically the graphing was too, but, yes. Yes, but what I just told them all was that the only thing you're going to have on your quiz is something like number 3. Okay, so we're solving systems now algebraically. So we did it by graphing, okay, and like I said, I'm only going to give you one of the easy problems, okay, on the quiz. Not going to give you one that's ridiculous. It'll be something that's just really easy to check. Okay, you do still need to understand if it's consistent or inconsistent, and then dependent or independent, okay, because that'll kind of just keep tying in with what we're doing, but it would be more so just if I say, here's the two equations, use this method to do it, not use the graphing method. Okay, so we have two methods that we can use to do this. Okay, we have the substitution method, meaning solve for a variable, take that, plug it in, and then, blinking here, hello, solve that new equation for that variable and stick it all back in. Okay, just in short, that's what we're doing. Elimination, you get two equations stacked up together. You offset one of the variables to cancel it out, solve for the variable, plug it back in, and solve it. Okay, that's just in short. It'll be a lot easier once we actually do it. But all the steps are laid out for you in your notes that I gave you that you'll watch the video for. If something is no solution, then we get something that's a false statement like 2 is equal to 4. Okay, that's not true. So if you get something like that, then it's a false statement. It's no solution. If you get something like 0 equals 0, 3 equals 3, things like that, it has infinitely many solutions. Okay, so let's just go ahead and start with some problems because, like I said, you guys should remember this from Algebra 1. So the first set of problems says to do it by substitution, okay? Not optional to pick your favorite method, okay? If it says you have to do it by a specific method, do it by that method, okay? Now, there will be some that say choose any method, then pick your favorite one or whichever one is easier based on the given problem. Okay, but these first ones are by substitution. So start with number 4. So we have 3x plus y is equal to 16. 2x minus 3y is equal to negative 4. Okay, so for the substitution method, I want to solve one of the equations for a variable, okay, and then I'm going to take that and plug it into the other equation. If there is a variable that's already by itself, like this y, okay, we want to solve for that variable. Okay, you don't have to do it that way, but that's the easiest way to save you time. So if I want to solve for y in this equation, what do I get? Or how do I do it? This is 3.2. Oh, no, plus 16. Okay, so now this is my new equation 1. Okay, this is modified equation 1. So now I'm going to take this negative 3x plus 16, and I'm going to put it in for y down here. Okay, so I have 2x minus 3 times negative 3x plus 16 is equal to negative 4. So now I have an equation that just has one variable in it. So now I need to solve for x. So what's the first thing I need to do? Okay, so that gives me okay, so then here I can combine like terms. I'm going to go ahead and add the 48 over. So 11x is equal to 44. So x is what? So x is 4. Okay, so I'm just going to circle that so I keep up with where it is. Now I'm going to take this and plug this into an equation. Okay, I can plug it into this modified equation to make my life easy because I ultimately need to know what y is. So y is equal to negative 3 times 4 plus 16. So what is y equal to? Four. Sorry, somebody said something, but I couldn't understand what they said. Okay, so how do I write my answer, though? As an ordered pair, okay, x first, then y. Okay, in this case, it doesn't really matter because they're both 4, but the answer is 4, 4. All right, let's see. 8. 3x minus 4y is equal to negative 5, and negative x plus 3y is equal to negative 5. It doesn't matter, it can be either one. Which one do you guys want to use? Which equation, top or bottom equation, and which variable? Bottom and which variable? X, so how do I get x by itself? Okay, so x is equal to 3y plus 5, so I'm taking this now and plugging it into this top equation where x is. So I get 3 times 3y plus 5 minus 4y is equal to negative 5. And I need to solve for y, so what do I need to do first? y equals negative 20. Y equals negative 4. Okay, so that's part of it. So now I'm going to take this, plug this back into this modified equation 2. So x is equal to 3 times negative 4 plus 5. Alright, so x is equal to negative 7, so then my ordered pair is what? Negative 7, negative 4. Okay, so just make sure you pay attention to if you solve for y or x first so you get them in the right order for your ordered pair. This one? This modified problem here. This is a modified equation 2. Alright. What? Yeah, you could plug it back into one of these original equations here and make sure that they work. Yeah, so if you want to check it, you can always plug it back in and check it, but I'm not going to require you to do that. No, just make sure you use one of the original ones, don't use your modified one. Just in case you made a mistake over here, use one of the original ones, because that'll show you if you did or not. Sure. 6x minus 3y is equal to 15. Negative 2x plus y is equal to negative 5. Alright, so before I stress you guys out, okay, it would be infinitely many solutions, okay? Depending, I know some of you said you got 0 is equal to 0. I'm not sure what equation you used to get 0 is equal to 0, but I have 15 is equal to 15, okay, which is always true, so it's infinitely many solutions. So after that, I'm done. Okay? I'll give you another one that's not like that. Oh, okay, that's fine. Yep, that works. Alright. Number 14, then. 2x plus 5y is equal to 10. Negative 3x plus y is equal to 36. Alright, do we get an answer?
Yeah.
It's our ordered pair. Beautiful. Okay, so first you solved the equation for y, okay, technically, or x, depending on, you know, how easy you wanted to make your life. To get 3x plus 36, plug that in for y. You end up getting x is negative 10, then plug that back into the modified equation and getting y is equal to 6.
I like it when 17
Yeah, I had, if you can't tell, I had 17x is equal to 190, and I was like, that doesn't work. Because I forgot to subtract it. I just was like, oh, 180 and 10. All right, any questions about the substitution method? No? Okay. All right, let's look at the elimination method now. I actually prefer elimination. Yep.
Nice. I like this.
4x minus 2y is equal to negative 16. I'll also teach you how to do these ones by hand. Or by hand now, but by calculator at the end of the chapter. Negative 3x plus 4y is equal to 12. So this will be another part of the test that has a calculator portion on it, or another test that has a calculator portion on it. Alright, so basically with elimination, okay, some people call it combination. It just depends on what book you have and what teacher you've had in the past. I always grew up on combination. The book uses elimination, so I've tried to like switch to that. Basically, I need to have it so that one of my variables cancels out completely. So I need to modify the whole equation to get it to cancel. You have a question? Okay. Yeah, so y seems like the easiest option, okay, because 2 and 4, their signs are already opposite. So what would I need to do to the top one? Okay, I'm going to multiply the whole thing by 2. Okay, or I could also, if I wanted to, okay, I could also do the bottom one by 1/2, but I don't want to deal with fractions, so it makes more sense to do the top one by 2. So then I get 8x minus 4y. And make sure you take it all the way over to the right side too. So 2 times negative 16 is negative 32. So now I'm getting rid of that equation. I'm done with it. Okay, I've modified it now. So now I'm going to add these two together. So 12 and negative 32 is negative 20. My y's cancel out. Okay, they're done. 8x minus 3x is 5x, so x is equal to negative 4. Book must like the number 4. So now I can take this and I can plug it into either equation, okay? If I'm going to use this top equation, let's say, don't use your modified one, okay? Use the original one. It's going to be easier. You've multiplied your equation by something that's going to make it a lot more difficult. So if you choose to use the one that you've modified, use the original equation to do that. So which one do you guys want to plug it into? The top one? Okay, so we're going to plug it into 4 times negative 4 minus 2y is equal to negative 16. Yeah. So this is negative 16 minus 2y is equal to negative 16. To add the 16 over, so negative 2y is equal to 0. Y is equal to 0. So then my ordered pair is what? Negative 4, 0. I multiplied the whole thing by 2. It won't always be 2. It depends. So let me see if I can find one that's not going to be 2. Yeah, so some of them you'll have to actually do something to like both equations for it to work. Like they won't be something where you can just multiply by one thing. You'll have to multiply like both of them sometimes. 18. 4x minus 3y is equal to 10. 8x minus 6y is equal to 20. X or y? What do I need? What do I need to multiply it by? Negative 2. Okay, so then I'm just going to write it underneath the bottom one. So this is going to be negative 8x plus 6y is equal to negative 20. Everything cancels, so I get 0 is equal to 0, which means what? Infinitely many solutions. Okay, so that would be your answer there, is infinitely many. Okay, you do still have to show me this step. You can't just look at these and be like, oh, infinitely many. You got to show me why here. Okay? All right, 22 is a good one. I'm going to set it up for you guys, and then I'll let you do it. I'm just multiplying this equation because I have to be able to cancel a variable.
Oh, no.
Okay. All right, so this one, 22, I have 7x plus 2y is equal to 11, and I have negative 2x plus 3y is equal to 29. Now, is there anything that I can multiply just one of these equations by to cancel one of the variables without using fractions? Okay, so then what I need to do, okay, is I need to do something to the top one and something to the bottom one, okay? Typically, the easiest thing to do is, well, y'all want to do x or y? Okay, if we're going to do y, okay, this one is 2y, this one is 3y. The easiest thing is to multiply the top one by 3 and the bottom one by 2. One of them has to be negative. I don't care which one, okay? So the top one, okay, multiplied by, let's just go ahead and do negative 3 on that one, and then the bottom one is going to be 2. Okay, sometimes their signs will already be opposite, so you won't have to change, you won't have to do the sign, but you would have to multiply it here, okay? Now, you can pick any number here, but 3 and 2 are going to be the smallest ones. Like, I could use 6, anything like that, okay? 6 and whatever, you know, I can find other numbers that work. So go from here, multiply out that stuff, get your modified equations, and then solve it from there. Because they're not the same. You don't have to, but yeah, it's easier to do it. All right, have we gotten an answer? What do we get? Negative 1,9. Okay, so you had two modified equations, okay, making them both 6y. Okay, one of them was negative, so the y's canceled, so you're left with negative 25x is equal to 25, so x is negative 1. And then you can pick either equation to plug it into. I chose the bottom one in the original. So that I got y is equal to 9. Any questions about these? Do we feel okay? Hold on, guys. There's a question somebody's asking. Because I have to have them so they cancel. So they wouldn't have canceled if I had just multiplied them by the number. So sometimes you just have to multiply, like say this had already been 3y here. If they were both just 3y, I would have had to multiply one equation by negative so that I could subtract, or so that I could cancel them out. Pretty much it looks like they're giving them all to you in the right order, so it should be fine. Alright, so I'm going to go ahead and give you guys a couple problems to do. Just know that it is possible for no solution. Okay, so when we had one like this, infinitely many, if I got something that was like 12 is equal to 2, okay, that would be no solution, okay, because we didn't actually do one like that. But if we need to do one tomorrow, we can. But there's not a ton of time, so I want to give you guys a couple of minutes to just try a couple on your own. We'll probably do a little bit more with this section tomorrow, to be honest with you, just because I want to make sure we understand it before we just keep moving on. And then if we have any questions from the section with graphing about anything, we'll go over all of that with homework. So I'll try to look at the homework problems that you guys have done. Okay? Yes, technically. Like 15 minutes. I'm only giving you a couple. Yes. Okay, I'm just giving you 4 problems for now because we need to go over the stuff about basically picking any method, okay, but I wanted to go over a couple of those and just how to decide what's the best method to actually use and stuff tomorrow. So we'll do that and probably review some of the other sections. So we'll see based on where we get tomorrow what we're going to do. But I do want you to go ahead and submit the 2 homeworks. So I'll make tabs for them.